Hey guys, so in this video we're going to continue talking about unitary operations and how they can operate on the qubits and state vectors we've already started talking about. So first of all, let's continue with what we started talking about in our previous unitary operations video, which was the Hadamard operation. And we defined the Hadamard matrix as H equal to this matrix. We can also write the Hadamard matrix as something a little more simple, which is just 1 over root 2 times the following matrix, 1, 1, 1, negative 1. That's a lot simpler way to write it. Now, what this matrix actually does, this operation, what it actually does is it allows us, if you recall what the ket plus and the ket minus states are, and how they are equal to either ket plus is equal to ket 0, 1 over root 2, plus 1 over root 2, ket 1, and then ket minus is equal to 1 over root 2, ket 0 minus 1 over root 2. Now, if we see, we can see how these are both quantum state vectors, but they both have the same alpha and beta values, just with different signs. So when we take the absolute value and square them, we get the same probability of both. Now, if we go back to our previous video, where we talked about how quantum computers actually find the true state vectors based on a probability distribution, notice how this plus and this minus give us the same distribution. They're both going to be 50-50 in the end. So what we can do is apply a Hadamard operation, or just multiply this Hadamard matrix by either one of these, either the ket plus or the ket minus, and that will give us either ket 0 or ket 1. So if we treat the Hadamard operator as an H acting on ket plus is going to be equal to ket 0, and H acting on ket minus is going to equal ket 1. And feel free to do the matrix multiplication yourself. It's just this times the column matrix of either 1 over root 2, when 1 over root 2, or 1 over root 2 and negative 1 over root 2. Feel free to do that. And also, we can see, based on the same matrix multiplication, that the inverse is true. So H of ket 0 is going to give us ket plus, and H of ket 1 is going to give us ket minus. Now, a key idea of Hadamard operations is that they are analogous to logic gates in classical computing. So we know the NOR gate, the AND gate, the OR gate, the NOT gate. These are all types of gates in classical computing. The Hadamard gate is a part of a new family of gates, but they're not classical gates, they're quantum gates. And these unitary operations just talk about how they operate on quantum state vectors, which give you more information and can operate on your quantum state vector, telling you things that you wouldn't normally uncover otherwise. So yeah, thanks guys, bye-bye.